All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue learning about Git. More specifically, we're going to be focusing on, I think we are done with branching for the most part. I think. I'm not, actually, no, we haven't, I don't think we've touched branching yet. For the time being, though, the page that I'm on is kind of touching on remotes. I don't think it's going very deep into remotes. I actually don't know if there is a dedicated section for remotes. Let's find out. Hold on. Give me a second. Let's look. So there's Git basics, Git branching, and I think Git on the server is about as close as it gets to remotes, but that's more about setting up um the tech for the remote server for the remote. I don't know what to call it, platform, location, basically the other place where you're going to have, your server set up, and the place where you're going to have your central repo set up from where you're going to be cloning and pulling and pushing and stuff. This section, from what I understand, it covers that. It is worth looking into more though. That being said, what I'm planning on doing is I'm going to be setting up, so we can go through like all of these um you know gradually at some point, but what I'm focusing on is a bare bones Git repo. That's going to be the local central repo that I'm setting up, and this is going to be like for each project. What I want to do is I want to set up two remotes. one remote One remote is going to point to um a local central repo, and that's going to be my main copy. And another remote is going to point to another central repo, which is on GitHub. Though, to be honest, that I'm not really considering that as my central repo. That is more so just for public facing repos that I also want to share, with the community. This is more so for that. I think what I want to do is give more weight, give more importance to my own local copy of the repo. So essentially self-hosting. That's what I want to give more importance to. That raises another question. Are there any services that I should be looking into for self-hosting? Because I'm gonna mention this to, I guess this is what we are starting our Yap sesh with. Um, or this is how we are starting the stream. This is what today's Yap sesh is gonna be. By the way, yesterday, after I think a good 2 months of not missing any streams, because I think the last time that I missed a stream was uh maybe in April. I don't remember. Um, so yeah, I would say after a good like 2 months, or at the very least month and a half of managing to stream daily, yesterday I decided to not stream. Um, though to be honest, the only reason I decided not to stream, so the reason I decided not to stream wasn't because I wanted to take a day off. The reason was because I was drinking. Because I had a celebration, I had a family celebration, and we were all drinking, and I didn't want to stream drunk, because there's certain things that I need to watch out for when I'm streaming, and I would much rather, be in my senses when I'm streaming, so I don't make mistakes that I might regret later on. Mistakes in the sense of like, accidentally revealing certain information on stream by accident that I didn't mean to reveal. Um, yeah, yeah. So that's why I decided to take a day off, and well, here I am today. Dude, I'm so happy that because like we are now uh, halfway through the fifth month of this year, and for the most part, I have managed to continue streaming daily, and I'm incredibly happy about that. For the most part, I've managed to stream daily, and that is something that I kind of had like a goal for this year. I really wanted to make sure that that I'm streaming more regularly. By the way, yeah, I just remembered there is a clip that I want to post on social media. Um, I'm gonna have to. So what I want to do is I want to clip it out of the stream, but I'm gonna set the thing up right now. I'm gonna like say I'm gonna, for lack of a better term, perform the clip right now on stream so I can later um, clip it out and post it to social media. What I'm going to be posting about is the head, and though I need to think about what I want to say about the head. So what we learned about was the concept of head. Head by default points to the latest commit, but it doesn't really point to the latest commit. What it points to is the latest. What it points to is a specific branch, and that branch points to its latest commit. Um, yeah, yeah. I need. I'm wondering if it would be better if I wrote this out, if I did a write up instead of doing it in video form, because I don't know if I might mess something up. Yeah, yeah, because there's some information that I wanna add in there as well. So I guess I'll not do that. Um, hold on. By the way, I need to uh write. Um, okay, okay, okay. Hey, so I'm planning on self-hosting my Git repos locally. Uh, by self-hosting, I mainly mean uh, using a bare repo as a central repo and having a separate clone that's my working copy. And I will have this set up for various projects, and the quote unquote central repos will all be in one location on the on a machine on my local network. What I'm wondering um, is there a quote unquote better way to go about this? Are there things I need to watch out for? Um, how? No. Are there things I should be looking into in terms of managing these quote unquote central repos? Also, let me know if I'm supposed to be calling them something other than central repos. Also, I have a primarily terminal based workflow, and I use Ubuntu. Just putting that info out there. Okay, so let's see what Gemini says. Also, I wanted to mention that, yeah, I'm on Linux because there tends to be, a tiny bit of platform differences between the way things are done on Windows and the way things are done on Ubuntu. When it comes to these kinds of things that are, fairly technical things, then you'll get a lot less friction on Linux. So I wanted to mention that, yeah, I'm on Linux. And additionally, I wanted to mention the TUI workflow because, or rather, sorry, the terminal-based workflow, because um, if Gemini is going to recommend any sort of, I don't know, like dashboard applications, um, anything like in terms of management, if Gemini is going to mention any sort of dashboard applications, I would prefer for them to be, either CLI or TUI or something terminal based rather than GUI. Okay, now, what did Gemini say? Uh, okay. First off, your terminology is totally fine. While Git is technically a distributed version control system, calling the main server-side repo the quote-unquote central repo or remote upstream is exactly how everyone thinks about it. Okay, good to know. What you are describing, using a bare Git repo on a local server and pushing slash pulling via SSH is the exact foundation that platforms like GitHub and GitLab are built on. Since you have a terminal-based workflow on Ubuntu, this approach is lightweight, incredibly fast, and fits your style perfectly. Here's a breakdown of how to optimize this setup, things to watch out for, and how to level up your management. The standard terminal setup, SSH plus bare repos. Since you already plan on using bare repos, the cleanest way to manage this on Ubuntu is via SSH. Instead of dealing with raw file paths, you treat your local machine just like GitHub. You create a bare repo on your server and you clone it on your local machine using your SSH config alias. Oh, that's how you do it. Okay, so you have to add the, yeah, I haven't gone into the um I haven't gone too deep into like the remotes thing. So I wasn't aware of how exactly you're supposed to go about cloning a repo. I've cloned repos from GitHub, but usually the the way to do that is you grab the link off of GitHub, and then in your terminal you type git clone and paste the link. But here it mentions you would have to do something like, actually I can copy this. Here it's mentioning that I would have to do something like this. Let me turn off spell check. Okay. Dude, I love NeoVim, dude. It is crazy the kind of stuff that I'm able to do with NeoVim and how much I've explored NeoVim and discovered so many different features within it. NeoVim is one of those, it's kind of crazy. And it's a similar situation with terminals like WesTerm. These programs, they are made to be extended. They are made with extensibility in mind. That being said, they have a lot of functionality that tends to be kind of hidden away, and you have to access them either by assigning keybinds or creating plugins that access that functionality or some other method. Sometimes there's functionality in these programs that you didn't even know was available, but it's available. NeoVim is like the best example of that because the whole reason why NeoVim is used is not because of NeoVim itself, but because of all the plugins that the community has made which together were able to form distributions. Distributions are essentially collections of configs and key maps and plugins, and also plugin managers. Usually, many of them tend to have plugin managers as well. But yeah, yeah. Okay, so continuing reading this. Pro tip: optimize your SSH config to keep your commands short. Set up an alias in your local so and so. Uh, okay. User git identity file so and so. Okay, is there a quote unquote better way tooling to look into? While raw bare repos work perfectly, managing 20 plus projects via raw SSH commands can eventually feel a bit tedious. Example, manually SSHing in just to run git init bare for a new project. Since you love the terminal, here are two excellent lightweight self-hosted management tools. One is Gitto Lite, the terminal purest choice. Okay, if you want to keep it 100% in the command line but want better management, look into Gitto Lite. How it works: you don't create repos on the server manually. Instead, there is a special central repository called Gitto Lite admin. Wait, instead, there's a special central repository called, okay, to create a new repo or change access permissions, you just edit it. You just edit a text file on your local machine, commit it, and push it to the server. Gitolite automatically creates the new bare repo. Oh, okay. Automatically creates the new bare repos on the server for you. And then option B is git t or for Joe. I'm not sure how to pronounce this, but it's written as Forgejo. So I don't know if that's Forgejo or um, Forge Joe. So like forge, the word forge. Let me look that up. Though, okay, yeah, there is Git T. I remember looking into Git T a while back. I also remember calling it Gitia initially, which, in my defense, the name is written in a way that would be confusing. Okay, it's supposed to be Git and tea as in a cup of tea, um, and they wrote it as Gitea. So I thought it's Gitia. Okay. Um. Okay. Yeah. So Git T is, I don't know. Does Git T have like a terminal based setup? I thought it's all GUI or maybe a web interface. It is. It does have an open source thing going on. They also have a cloud thing that you can set up. Hold on. The the goal of this project is to make the easiest, fastest, and most painless way to set up a self-hosted Git service. As Git is written in Go, it works across all platforms and architectures that are supported by Go, including Linux, Mac OS, and Windows on x86, AMD 64, ARM, and PowerPC architectures. This project has been forked from Go GS from GOGS, Go GS. Okay, whatever. For online demonstrations, so and so for accessing the free Git T service with a limited number of repos, you can visit so and so to quickly deploy your own dedicated Git T service, sorry, instance on Git T Cloud. You can start a free trial at so and so. Okay, hold on. So know, I need to know if, so okay, I'm gonna need to have a server running. I need to also see how, um, what kind of load this extra server that I'm running is gonna carry. Um, okay, hold on. Oh, they mentioned here, if you want a simple web interface, okay, it mentions web interface. Okay, if you want a simple web interface to view your code history, track issues, or look at markdown files without bloating your, so wait, it has a markdown renderer as well? Okay, good to know. Without bloating your server, Git T is fantastic. It's a single binary written in Go, uses almost zero RAM/CPU, and takes 5 minutes to set up. It gives you a GitHub-like UI, but is perfectly happy letting you interact with it entirely via the command line. Things to watch out for: the backup trap. Crucial. When you use GitHub, um, they handle, when you use GitHub, they handle replication. When you self-host, if the local server's drive dies, your central history dies. Even though you have a working copy on your local machine, your working copy might not have all the branches, tags, or hooks. The fix: set up a cron job on your Ubuntu server to automatically back up your bare repos directory to an external drive or a NAS, or NAS is, I believe, network attached storage, or an encrypted cloud storage bucket using tools like Restic or what is this called? Borg Backup. Okay, hooks and permissions. If you use a standard user account on the server, ensure your local machine's SSH key maps to a dedicated limited Git user on the server. If multiple people or multiple devices of yours use different system users to push to the same bare repo, you will run into permission errors because user A created a file in the repo that user B cannot overwrite. Okay, automation. If you are used to GitHub Actions, I'm actually not used to GitHub Actions. Not I haven't touched GitHub Actions at all. I should look into that at some point because there's a bit of automation that uh, GitHub Actions enables. Um, I should also look into to what extent are we allowed to use that for free, and at what point does it become a paid service? First, I need to understand what it's all about. Um, yeah, yeah. You can utilize. Oh, wait. Automation, CI/CD. If you are used to GitHub Actions running tests when you push, you'll lose that out of the box. You can utilize Git server-side hooks. It's just a shell script that executes on your server the moment a successful Git push happens. You can use it to trigger local test scripts, send a notification, or deploy code to a local web server. Okay, okay, okay. Hold on. So there's a couple of things that I need to ask. First of all, let's look into Gitto Lite. Gitto Lite. Gitto Lite allows you to set up Git hosting on a central server with very fine grained access control and many. Hold on. The description is gone. Uh, okay, for anything more, you need to look at the complete documentation. Please go there for what, why, how concepts. All right. Assumptions. You are familiar with the OS, at least one Unix-like OS, familiar with SSH keys, SSH authorized keys file, and Git, basics of Git, bare and non-bare remotes. Okay. Another assumption, you are setting up a fresh SSH-based installation of Ghetto Lite or on a Unix machine of some sort, and you have root access or someone has created a user ID called Git for you to use and given you a password for it. Okay, if your server is not connected to the internet, wait, give me a second. Okay, if your server is not connected to the internet, you know how to clone the Gitolite source code by using some in-between server or Git bundle. I didn't even know that that's an option. Okay, cool. That being said, I don't think this is something I need to get into right now. Yeah, I don't think this is something I need to get into right now. Though I do want to ask this question. Okay, so couple of things. Um, I haven't fully understood how Ghetto Lite works. You mentioned a central repo, a central Ghetto Lite repo. Do all my other central repos go into this? Like, how does that even work? And then, is Git T free when I'm self-hosting? I don't mind a web UI for uh, central. I actually do mind it. I would prefer if there was some CLI way of doing it, but it does mention that you can do it through CLI. I don't mind a web UI. Wait, hold on. Hold on. Wait. Um, Let me look up Git repo management TUI. Okay, we have Git UI. This is for, okay, I built a TUI to manage all my Git repos because I kept, okay, somebody made something called Git scope. And then there's something called repo lice or repolice. TUI to handle Git repository management. Git repo management TUI. Yeah, that's what I wrote. Okay. Then there's GH manager CLI. This is a TUI terminal Git repo. Okay. GUI clients. Wait. Oh, the Git. What do you call it? Hold on. There is a tools section here. We can open up this tools section. Command line tools, GUIs, hosting, Git repository hosting, tools to view and manipulate. Um, I'm not looking for GUIs, but I'm hoping that in the GUIs section, they also mention TUIs. Okay. Okay. All right. Wait. Oh, okay. So these two options are here as well. We can look into these two. I guess let's open Git T as well. Oh yeah, somebody had made a thing to. Okay, if anyone here works on multiple repos, curious what part of your workflow slows you down the most. Okay, so this person is actively working on the repo, which is great. Okay, the thing is made in Go. Hold on. Yeah, this is great. This is great. Though I guess, I should sit down and think about I what problem am I trying to solve? Because I'm looking for TUIs, right? I'm looking for management ways. I don't yet know what exactly I am trying to manage. Because if it's just about listing out Git repos, all of the repos, all the central repos are going to be in one central location on the file system. So like if I do list them out, what more am I expecting? Like you get what I'm saying? I feel like I don't fully have a need for a management tool right now, if that makes sense. I'm just kind of like I'm kind of window shopping, I guess. Something that I could do is I could write a tool, a TUI tool, um, to traverse a directory, or maybe it can read a config file, and in the config file I can list out all the repos that I wanted to track, and then it can track those repos, and for each repo it can list out information like, but then I don't need that. I don't really need to recreate the functionality myself, because like, okay, we've got git repo. Wait, what was I trying to say there? I wasn't trying to say we've got git repo. We've I lost my train of thought. So okay, we have the the central location where all the central repos are. Okay, I can write a tool that can like traverse uh, a list of Git repos that I give it, and then it can display various information about those repos. I'm pretty sure I'm going to find a library uh, that allows me to query information about repos, so I'm not going to have to, do a whole bunch of parsing myself. I'm not going to have to do a whole bunch of like, go into this file and find this information, detect which branches it has, and all of that stuff. I'm not going to have to do it myself. I'm absolutely sure there's going to be some sort of library that already allows me to do that. Just a minute here, guys. All right. So, yeah, I guess I don't need something, because I'm trying to think of like what what am I trying to what am I trying to do exactly? What problem am I trying to solve? I need to think about that first, and then based on that, I can decide that, oh, these are the features that I need, and so this is the tool that I need. Because I feel like I'm not going to be doing a whole bunch of like extra stuff. I should also learn about how bare repos work, because my understanding is that bare repos are uh, they are not meant to be working copies. So you can't really work in them. All you can do is push to them and pull from them. uh, there's probably more stuff that you can do as well, but you can't use them. Apparently, you can't use those bare repos as like a working copy. In order to get a working copy, you have to clone from that bare repo, and then that creates a working copy for you, which you can then work in. There are advantages of this as well. I'm guessing there's more compression applied there, and so because there isn't like a working copy there, so Git is able to apply more optimization in order to make the overall size of that bare repo much smaller. This is my assumption. I could be wrong. I guess we'll find out later on once I start using it. But yeah, I don't think I need to look into any of these applications. Yeah. I don't think I need to right now. Gitolite allows you to set up Git hosting on a central server with fine-grained access control and many more powerful features. The source code is at Codeberg. Wherever the documentation mentions the above URL, you can also use the alternate URL so and so. Okay. If that ever changes, this section will be updated. If your Unix foo and SSH foo are good, that's crazy. Are good, uh, take a look at the quick install page. Otherwise, follow the documentation flow using the next and previous buttons at the bottom of each page, skipping whatever you think you don't need. Okay. Um, okay. All right. I guess hold on. Give me Yeah, let me just stop this RTMP feed temporarily because my fans have been getting pretty loud. Okay, all right. So, what is Gitolite? Gitolite is an access control layer on top of Git. Here are many features that most people see. Use a single Unix user on the server. Provide access to many Gitolite users. They are not real users, so they don't get shell access. Control access to many repositories. Read access controlled at the repo level, and write access controlled at the branch slash tag slash file slash directory level, including who can rewind, create, or including who can rewind, create, or delete. Oh, rewind, create, and delete branches and tags. Sorry, got stuck there for a second. Um, okay, dude. So I'm just doing. I'm the only one who's, pushing and pulling. This is like a single user, a solo user kind of thing. Um, okay. So they have a thing here asking, okay, why might you need it? Access control. Git by itself does not have any access control. It relies on the transport medium to do the authentication, such as who are you, and on OS file permissions to do authorization, such as what are you allowed to do. I didn't know that. Okay, interesting. Git also comes with a program called Git Shell, which can act as a restricted login shell if you don't want users getting a proper shell. Using this and judicious use of Unix groups can allow you can sorry what of Unix groups you can allow some people read only access while others get read write access, etc. This is probably sufficient if your needs are simple and don't change often. However, Gitolite does this much better and offers many more features. Basic use case. Gitolite is useful in any server that is going to host multiple Git repos, each with many developers, where anyone can do anything to any repo is not a good idea. Okay, so I'm starting to realize why I don't need Gitolite. For one thing, I'm the only user, right? This is incredibly useful when you have teams working and not every developer, not every user is supposed to have the same read write access. Not every user is supposed to be able to do every single thing. This is when you actually want to manage permissions properly. I don't need this right now. I definitely don't need this right now. Yeah, okay. You know what? Man, that was a hell of a yap sesh. That was a hell of a yap sesh, dude. Uh, I think I think we are good there. Um, yeah, I think I'll stick with my central repos directory kind of thing. Whenever I do actually need a tool that needs to be able to do something, I still don't know what that something is. The problem is that I headed into this research, headed into this query without actually knowing what problem I'm trying to solve. And honestly, I think I was just trying to explore what the possibilities are. Yeah, sorry, zoned out. Okay, um, right. So we're gonna close this and we're gonna go. Actually, let's look at this a little bit. It doesn't seem like any of these are going to be TUIs at all. Yeah, they all seem to be GUIs. Oh, there's a TUI slash CLI. Fugitive. Licenses Vim. There's a Vim license? Hold on. Fugitive TUI. Vim Fugitive is just a superior way to manage your Git so and so. Lazy Git is a TUI, and Fugitive is a NeoVim plugin. It's called Vim Fugitive. Hold on, Vim Fugitive. Okay, fugitive.vim, a Git wrapper so awesome it should be illegal. Fugitive is a premier Vim plugin for Git, or maybe it's just a premier Git plugin for Vim. Okay. Either way, it's so awesome. It should be illegal. That's why it's called fugitive. Okay. Okay. Now I get it. Somehow it didn't click, illegal, fugitive. Anyways, the crown the crown jewel of fugitive is so and so, which calls any arbitrary git command. If you know how to use git at the command line, you know how to use fugitive, I'm assuming. It's vaguely akin to so and so with numerous improvements. Um, I don't think I need this. I don't think I need this right now. Lazy Git. Okay. Um, Tig. I think I think I've looked into Tig. I think so. Git UI, that's what I'm using. Pretty amazing application. Um, okay, okay. Damn, there's so many tools. Holy shit. That's pretty awesome, dude. Git Kraken. I've heard this being mentioned. Also, apparently there's free slash $48 per user annually. This is a proprietary application. Okay. Um, yeah. Okay. All right. Wait, there are other great GUI tools available as well. Have a look here. Oh, there's an even longer list. Okay, that's interesting. Obsolete content. Hold on. Let me. Okay, graphical interfaces. I think for the time being, I am looking for like, okay, graphical interfaces. Okay, okay. Git UI is mentioned directly under graphical user interfaces. So I'm guessing this entire list contains like a mix of GUI and TUI. And there's web interfaces, tools. Okay, this is a fairly long list. And again, I don't really, yeah, I don't need to look into this too much right now. For the time being, I guess let's continue reading about remotes. Where are we? I was supposed to be in remotes. Okay, let's just click on this. Okay, all right. Yeah, we'll read this. I guess I can start up the. Oh, you know what? Give me a second. I'm gonna take a short break, like 2, 3 minutes. I'll be back, and then we can continue. Okay. I am gonna switch to BRB, and hopefully this time I remember to mute my mic. But yeah, I'm gonna switch to BRB, and yeah, I'll be back. All right, I am back. Let me get this RTMP server started again, and then we should be able to continue. Give me a second here. Let me just refresh this. Okay, cool. So, uh, give me another second here. Okay, all right. Let's continue reading and learning about Git remotes. Dude, once I have this knowledge, I'm going to be using this extensively um, in various ways. I'm pretty sure even the branching thing, I'm going to be using it extensively for various projects that I'm working on. It'll allow me to test out different features, especially for the more serious projects that I'm working on. It'll allow me to test out the features. Also, I've got so many projects that I've been wanting to um, push to GitHub. First of all, there were certain projects that I wanted to put up on GitHub just for the sake of having a backup of it. Um, but now I'm like, okay, let's create a central repo and let's also put it up on GitHub if it's something that I'm willing to, share on GitHub. And I guess quite a few of them, I'm going to be willing to share them on GitHub because there's going to be a major advantage of sharing it on GitHub. And that is if my local copy ever goes down, then I still have the GitHub version because the GitHub central repo and my local central repo are always going to be synced up because I'm going to be pushing to both of the remotes at once. In fact, if I remember right, Gemini was mentioning that remotes can point to two locations at once as well. They're not limited to one. I need to explore that part more and um, see how that whole thing works. Because that would make things a lot simpler as well, right? Because I know that whenever I'm pushing to my local central repo, I also simultaneously want to push to the GitHub central repo. These are literally two separate central repos that I'm maintaining on purpose. One is so that I can have my own local copy, and the other is so that there's a public facing cloud hosted copy. But yeah. Okay. So Git basics, working with remotes. To be able to collaborate on any Git project, actually, I think I'm going to be doing a whole lot of reading here, right? So what we can do is I will turn off the RTMP feed so my fans can relax a little. And I'm going to increase the size of this window, the browser window. Dude, I need to work on that tool. The OBS WebSockets tool that I wanted to create, that where I would so my plan was there's going to be this tool eventually. Once I'm comfortable with Ratatouille, then I'll introduce a TUI into it. But for the time being, it's going to be just like a CLI based thing. The plan there was that I'll have this tool, and in the tool I can specify key bindings which would take certain actions. So one key binding would, let's say, it would switch between the BRB screen and this current screen. Another key binding would, in the current screen, look for the, not look, but actually, yeah, look. Well, I'm gonna have to make sure that I get the names right. The names of the sources, I mean. So this browser window, for example, I want to make it so there's a key binding where I can switch between different sizes and positions for this, because earlier this was much smaller and it was in the bottom left of the screen. Now it's much bigger and it's in the bottom right of the screen. And this, I usually only do this when I want to be able to read the thing and I want to show on stream what I'm reading. And it doesn't matter if whatever is behind is being occluded in some way, then I use this kind of a setup. But otherwise, I want to usually have this browser window be much smaller and be in the bottom left so that all of the other stuff can be seen, like um, the two tmux windows and the matrix rain, and mainly it's those things that get covered up. So I wanna have a key binding that lets me switch. Um, it lets me. Um, how do I say this? I want a key binding that lets me toggle between two different states for this browser window source. In one state, it's going to be in the bottom left and much smaller. So it's going to be in a specific position and a specific size. And then in another state, it's going to be in the bottom right and much bigger, like right now. So it's going to be in a specific position and a certain size. And then there's going to be a couple of other things as well that I want to look into, like maybe the ability to refresh the RTMP feed whenever I want. So I don't have to come into OBS in order to do that. I can just control it from, the external application. And probably a couple of other things. Now, here's the thing, right? In order to make this extensible, so I'm not constantly editing, what do you call it? In order to make this extensible so that I'm not constantly editing the source code, I want to introduce Lua into this, but I feel like that might overcomplicate things. I'll have to see how I want to introduce Lua into it. Like, obviously, I'm going to need a Lua runtime, but the idea is that once I've compiled the program, then all I need to do in order to configure it is uh, set up a Lua file and specify certain like key bindings that trigger certain actions. Yeah, yeah. Okay. All right. So, yeah, sorry. I just kind of zoned out. Right. Let's continue reading this. Okay. To be able to collaborate on any Git project, you need to know how to manage your remote repositories. Remote repositories are versions of your project that are hosted on the internet or network somewhere. You can have several of them, each of which generally is either read only or read write for you. Collaborating with others involves managing these remote repositories and pushing and pulling data to and from them when you need to share work. Managing remote repos includes knowing how to add remote repositories, remove Wait, it includes knowing how to add remote repositories, remove remotes that are no longer valid, manage manage various remote branches, and define them as being tracked or not, and more. In this section, we'll cover some of these remote management skills. Note, remote repositories can be on your local machine. It is entirely possible that you can be working with a quote unquote remote remote repository that is in fact on the same host as you are. The word remote doesn't necessarily imply that the repo is somewhere else on the network or internet, only that it is elsewhere. Working with such a remote repository would still involve all the standard pushing, pulling, and fetching operations as with any other remote. I kind of want to refresh my knowledge of what the limitations are with a bare repo. Hold on, I'm going to ask Gemini a question here. Hey, so I plan on hosting my own Git repos locally. The idea is that for each project, I will have a quote unquote central repo um, hosted either on the same machine or another machine across the network. Um, and then through SSH, I will clone the repo, um, push, pull, fetch, etc. Now, this has me wondering something. I know that I would be able to, because, okay, what I'm trying to understand here is that that whole thing about, like in the past, Gemini told me that apparently you can't work on the central repo, on a bare repo, because there's no working tree there, or working directory, I think it's called. There's no working directory there. It's only meant for you to use as a central repo. You're not meant to work in it. You're just meant to clone it and push and pull and, well, fetch and whatever other such operations. You're not meant to make commits to it directly. Okay, I know that I won't. I know that I would be able to. What was I planning on saying here? Oh, I know that I would be able to, quote unquote, do work. Well, that doesn't need to be in quotes. I would be able to make changes. No, let's just say commit changes. Commit changes to the clone. However, in the past, you have mentioned that the bare repo cannot be worked in/on directly. It is, oh, okay, cannot be worked in/on directly. Um, so I'm wondering why that is, and what makes that the case. Okay, it's awesome that you're setting up your own local Git infrastructure using a central machine over SSH is exactly how the quote unquote big players like GitHub or GitLab work under the hood. To understand why you can't work directly inside the central repository, we have to look at the anatomy of a Git repository and what a bare repo actually is. The anatomy, standard versus bare repositories. When you run Git init, normally on your local machine, Git creates two things in that folder. One, the working tree or working directory. This is the actual folder where your project files live. You can see your .py, .js, or .txt files, edit them, and compile them. And then you have the Git directory. This is the .git folder. This is a hidden folder that contains all the version history, commits, branches, and configuration. This is the actual repository. A bare repository created via git init bare is stripped down. It is only the contents of that hidden git folder dumped straight into the main directory. It completely lacks a working tree. There are no actual project files for you to open, edit, or compile. Why you can't and shouldn't work in a bare repo? Because a bare repo lacks the working tree, there is physically no space for you to modify files. But why can't we just use a standard repository as our central hub and push to that? Git actively blocks you from pushing to the active branch of a non-bare repository. Here's why. The desynchronization nightmare. Imagine your central repo is a standard repo and it currently has main checked out. On your local machine, you make some changes, commit them, and run git push origin main. If Git allowed this, the central repository's history or Git folder would update to include your new commit. However, the working tree, which is the actual files sitting on that server's hard drive, would not change automatically. I don't think I understood that. Hold on. Imagine your central repo is a standard repo and it currently has main checked out. Okay. All right. Our central repo is a standard repo. It has main checked out. I'm assuming if it's not a standard repo, if it's a bare repo, then you don't have the concept of something being checked out right now. I'm guessing that's the case. Let me open up another Gemini conversation. Hey, so in Git, when I use a bare, wait, in Git, does a bare repo have the concept of checking out? Because um, a repo, no, a bare repo doesn't have a working directory, right? It mainly stores the Git folder, the Git directory. And actually, okay, wait. So whatever is currently checked out, it affects the head, and the head affects what your next commit attaches to, or what your next commit, um, what your next commit is going to be in front of. Um, since it affects what your next commit is going to be in front of, we do not need the concept of a head in a bare repo, right? Let me present it in that way. Um, because a bare repo doesn't have a working directory, yeah, because a bare repo doesn't have a working directory, right? It mainly stores the Git directory, um, and I'm assuming it doesn't necessarily need, hold on, necessarily there, need a head either, since we can't make commits to a bare repo. You've actually hit the nail on the head regarding the working directory, but there's one minor misconception about head. Let's break down exactly how a bare repo operates. Does a bare repo have the concept of checking out? No, because a bare repo lacks a working directory, you cannot quote unquote check out a branch or view or edit, sorry, check out a branch to view or edit files. If you try to run git checkout inside a bare repo, Git will throw an error saying this operation must be run in a work tree. You are 100% correct about the structure. A normal repo contains a Git folder, that's the repo history and the working directory. A bare repo is just the contents of the Git folder, usually named with a, a .git extension. So project.git. That's good to keep in mind actually. Okay, it is stripped it is stripped of the working tree to save space and prevent conflicts, making it ideal for central servers like GitHub, GitLab, or a local server. The misconception: does a bare repo need a head? Surprisingly, yes, it absolutely needs a head file. Even though you can't make commits directly inside a bare repo, head serves a crucial purpose. In Git, head is a reference that points to the default branch, usually main or master. Here's why a bare repo requires a head. The default clone branch. When a developer clones when a developer clones from a bare repo, their local Git client asks the bare repo, which branch should I check out by default? Oh shit, are we dropping frames? Oh god, we've been dropping frames. We have been dropping frames for a bit. Well, okay. Um, which branch should I check out by default? The bare repo looks at its head file to give the answer. Okay. If head points to ref heads main, the developer gets the main branch. Then remote tracking. The head tells remote users which branch is considered the primary branch of the project. If you peek inside a bare repo's head file, you will see it looks exactly like a normal repos. Can you make commits to a bare repo? You can't make them directly within the bare repo itself, but you can push commits to it from a local repo. When you run git push origin main, the bare repo accepts those commits and updates its branch references accordingly. So while it doesn't need head to track a local author's active typing, it needs head to act as the traffic controller for everyone cloning from it. Okay, good to know. Now back to the other bare repo question that Gemini was answering. So Gemini presented this scenario. Imagine your central repo is a standard repo and it currently has main checked out. On your local machine, you make some changes, commit them, and run git push. Okay, so from our local repo, so both of these are standard repos. One is not a bare repo. The central repo is not a bare repo right now. They're both standard repos. Okay. On your local machine, you make some changes and commit them and run git push origin main. So now we are pushing those changes to what's supposed to be our central repo. If Git allows this, the central repository's history, that is the Git folder, would update to include the new commit. However, the working tree, the actual files sitting on the server's hard drive, would not change automatically. The server, oh, okay, so that's how we'll have a desync. Okay, the server would now be in a bizarre, confusing state. The files on the disk would look like the old commit, but Git would think it's on the new commit. If someone then sat down at the central machine and tried to work, Git would Git would think they had manually deleted or altered a bunch of code. Okay, then the shared hub principle. Central repositories are meant to be a storage and synchronization hub, not a workspace. That is actually a good, that's a good philosophy to go by. That's a good, I'm sorry, I'm not able to think of the word to use there, but that's a good logic to follow. Um, Though I'm wondering why is it that when code gets pushed, like okay, let's say it were a central repo. Okay, I'm going to use the scenario that Gemini proposed here. The server would be in a bizarre so and so, so and so, so and so. Okay, I'm going to open up a new conversation. Okay, in another convo, I was having with you about um, why you can't make commits to a bare repo. You explained it very well with um, the following example. Um, while I understood it, this did raise a question for me. Why is it that Git doesn't change? Oh, what if somebody is actively working on it? Yeah, okay, that could be a problem. What if somebody is actively working on that? That would yeah, okay. No, that would become a problem. That would become a problem. Okay, while I understood, this did raise a question for me. Why is it that Git doesn't um, immediately sync up the local uh, sync up the bare repo? No, not the bare repo. The central repos. Um, keep in mind, even the central repo is standard here, not bare. Local files to match whatever has just been updated. One scenario where I can see that kind of breaking is if someone is actively working on files in that standard central repo, and then Git tries to sync things up, and it's a mess of changes now. Okay, you hit the nail on the head. Okay, you hit the nail on the head. Your intuition is exactly why Git behaves this way. The scenario you described, someone actively working on the remote machine while a push comes in, is the primary reason Git blocks this by default. However, the technical reason runs a bit deeper into Git's core architecture and its philosophy as a distributed version control system. Here's exactly why Git doesn't automatically sync the working tree on a standard repository during a push. The dirty working tree nightmare, your scenario. Imagine you are logged into that central server, debugging a production issue. Give me a second here. Okay. Debugging a production issue. You've spent an hour modifying server.js, but you haven't committed your changes yet. Your working tree is quote unquote dirty. Okay. Suddenly, a teammate pushes a completely different set of updates to server.js from their local machine. If Git automatically updated the server's working tree, it would face an impossible choice. So then there's something similar to a merge conflict where um, it's not able to merge two two changes together, two versions together, because certain points in the file, they tend to have they're having like specific data in them. So rather than putting them on different lines, Git is like, stop, you fix this merge conflict yourself, and then try to commit the thing again. I don't remember the exact scenario, like is it line based or if it was based on something else, but this is one scenario where merge conflicts can occur. And well, this scenario that's being described right now is also an example of that. Overrides. It could override your uncommitted changes, causing you to lose an hour of work. Forced merges. It could try to merge the teammate's push into your live uncommitted files, potentially introducing syntax errors and crashing the active application. To prevent this data loss, Git safely refuses to touch the working tree during an external push. Then the index. Git add gets completely decoupled. In Git, there's a crucial middleman between your working tree, which is the files you see, and the repository's history, which is a Git folder. This middleman is the index or the staging area. Yeah, I just realized that I haven't found a way to explore the index. I should see if there are any subcommands in Git that allow you to explore the index file just to see what the staging area looks like. Okay, when a developer pushes to a non-bare repo, the remote Git directory receives the new commits. When a developer pushes to a non-bare repo, the remote Git directory receives the new commits. The remote head pointer moves forward to point to the newest commit. Crucially, neither the index nor the working tree on that remote machine are updated. Okay, okay, all right. Now, yep, I'm slowly getting it. Okay, because the remote head moved forward, but the index and working tree stayed behind, the remote repo is left in a detached state of awareness. The working tree files suddenly match an older commit, while head points to the new one. If you ran git if you ran git status on that server, sorry, zoned out. Where was I? If you ran git status on that server, Git would see the files from the old commit as if they were uncommitted modifications or deletions. Then Git's philosophy. Pushing is for history, pulling is for files. In Git's architectural design, pushing is intended to be a lightweight metadata transfer. You are sending compressed object files and updating a text pointer, the branch ref, in the .git directory. It is designed to be fast and safe. Updating a working tree, however, requires file system I/O. It involves checking out files, creating directories, and deleting old assets. Okay, all right. In Git's philosophy, pushing modifies the Git directory only. Pulling slash checking out modifies the working tree. Forcing a push to alter the file system in another machine breaks this separation of concerns. Can you actually force Git to do this? Yes. If you have a specific use case, like a simple automated deployment pipeline where nobody ever works directly on the server, you can tell Git to override the safety feature. In modern versions of Git, you can set a configuration option on the central standard repository called receive.deny current branch update instead. While update instead and with update instead enabled, if you push to the currently checked out branch, Git will check the server's working tree first. If the server has any uncommitted changes, the push will fail safely. If the server's working tree is perfect, oh, so the working tree has to be clean. Okay. Git will accept the push and automatically update the files on the disk to match. But because of the risks, Git forces you to opt into this behavior manually. By default, it protects you from the mess. Actually, you know what? That makes sense. That makes perfect sense. Sense. That makes perfect sense, and I understand now why um, the bare repo is like that. As in, you can't make commits to it. Okay. I'm going back to the old conversation about understanding the bare repos. The shared hub principle. Central repos are meant to be a storage and synchronization hub, not a workspace. Standard repo is optimized for a single user to create changes, so it has a working tree. The bare repo is optimized for multiple users to share changes, and it has no working tree, meaning no one can get out of sync. How it works in practice: when you push from your local clone to your new SSH hosted bare repo, you are doing a pure data transfer. You are sending compressed Git objects, commits, trees, blobs, etc., directly into Git's database structure on the server. Because there is no working directory on the server, Git doesn't have to worry about merging files on a disk or managing a user's uncommitted changes. It just accepts the data, updates its pointers, like where main points, and waits for the next person to run git fetch or git pull. If you ever need to see or test the code on that server, on that central server itself, the solution is exactly what you planned. You simply create a separate normal clone of the bare repo into a different folder on that machine. Okay, all right. So that answers that question. Now we can go back to reading this. Okay, wait, did I finish reading this note? Working with such a remote repository would still involve all the standard. Yeah, okay, that's done. Showing your remotes to see which remote servers you have configured. So here they had given this I don't remember if I still have tick git. I did clone it though. Wait, let's open up Yahtzee. And yeah, it's not here. It is not here. I did clone it, and then I probably deleted it as well. Yeah, yeah. Okay, I think we are dropping frames again. Yes, we are dropping frames. So give me a second here. I'm gonna try and do something to fix that issue. While this stabilizes, I'm just going to hydrate and then we'll continue. Okay, all right. Hopefully everything should be fine now. Give me a second. Yeah, okay, all right. Okay, so showing your remotes. To see which remote servers you have configured, you can run the git remote command. It lists the short names of each remote handle you've specified. If you've cloned your repo, you should at least see origin. That is the default name Git gives to the server you clone from. Okay, you know what? Let's clone the thing again. Let's do git clone https github.com/ this person's name slash tick git. Okay. Um, first things first, let's go into tick git and open up Siri here. Interesting. Actually, this is opening it up in. So you guys are not going to see the symbols that we could be seeing. How do I make it so you guys can see it? Wait. Oh, wait. I just realized that. Yeah. Um, hold up. I need to make the browser. First of all, I need to turn on the RTMP feed again, but wait. Is that good? Yeah. So I need to turn on the RTMP feed again, and then I can show you guys the tmux thing. However, um, additionally, give me a second. Let's refresh this. Okay. So what I'm going to do here is, I could just create a new tab. Yeah, I'll just create a new tab. Hopefully this doesn't take too long. Okay, I would also need to zoom in here. Would I need to zoom in? I don't think so. Okay. Let's open up Siri. Yeah, here it is. So you can see the commits. You can also hopefully see symbols on the left side. That's kind of why I was actually, no, you can't see it because it is probably zoomed in. I'm not, wait, hold on. I can't tell if you guys are able to see the symbols on the left side or not. Okay, well, probably now you'll be able to see more stuff on the left side. Hold on. Yeah, yeah. You can see. So a certain portion of it is cut off on the left side. But yeah, you can see some symbols on this. It doesn't show up in tmux though. There was a specific reason for that. I didn't bother trying to fix it because it wasn't too much of an issue. Um, though, uh, to be honest, I one of the things that kind of attracted me to this tool was the commit graph, like that the you know the graph feature on the left side, the graph, um, being able to view the graph on the left side. That was kind of one of the things that attracted me to this tool. But yeah, okay. So this is um, these are the commits. We I forgot what the shortcuts were. How do we view remotes? Okay, commit list, details, ref. I think it's ref list. Close ref list, open node, open copy. No, how do we open the ref list? The ref list? Ref list. How do we open the ref list? Show commit details. There was a way to view branches. Um, scroll, scroll, select. There, open ref list. It's tab. There it is. And these are, wait, this is interesting. So under origin, it's got all of this. I'm assuming these are, this is master, right? So I'm assuming, wait, this is interesting. Like, how is this working? So under remotes, we have origin. Um, origin is the name of the remote. And under that, we have branches, right? But here under origin, we have dependabot, and then we have a bunch of other stuff. What is dependabot supposed to be doing in this directory? Also, yeah, dude, no, I need to understand. I need to understand what's going on here. Okay, all right. Let's continue reading. Okay, showing your remotes. To see, oh, you know what else I could do? Wait, back up. I could open this up in Git UI directly and then view the branches and remotes through that. How do we see? Well, branches, I think it's just B, isn't it? Yeah, branches is B. Where is remotes? I think that comes under branches. Yeah, branches, we have the master branch, remote. All right. Okay, cool. So we have like a good, example to look at here. So let's see. Actually, let's close this and look at the remotes from here. Okay, git remote. It just says origin. You can also specify the V flag, which shows you the URLs that Git has stored for the shorthand, name to be used when reading and writing to that remote. All right. Okay. If you have more than one remote, the command lists them all. For example, a repository with multiple remotes for working with several collaborators might look something like this. A repository with multiple remotes. So here we are talking about the central repo? No. Wait, so do all the people that have copies of this repo, do they all see this list? Meaning anybody can pull from anyone and anyone can push to anyone? Like, is that the case? Though I guess based on Git's philosophy, um it would fail if you're trying to push to a standard repo which has a dirty working tree or a dirty tree. Okay, this means you can pull contributions from any of these users pretty easily. We may additionally have permissions to push to one or more of these, though we can't tell that here. Notice that these remotes use a variety of protocols. Oh, yeah, I just noticed that. Okay, so we have HTTP, we have Git, and then we have also something being done through email. Okay. I forgot what this was for. We had looked into something similar to this earlier. Oh, I think it was hosting it locally. Though I think just Git works for that. I don't remember. Okay. All right. Adding remote repositories. We've mentioned and given some demonstration of how the git clone command implicitly adds the origin remote for you. Here's how to add a new remote explicitly. To add a new remote git repository as a short name you can reference easily, run so and so, so and so. Okay. All right, let's try that. So git remote add pb https github.com/Paul Boone slash git no tick git. Oh, I just realized tick git is probably supposed to be kind of like how when people say ticket. I just realized that. Okay, okay. So we added the remote, then git remote v. Okay, cool. Now you can use the string pb on the command line instead of the whole URL. For example, if you want to fetch all the information that Paul has, but that you don't yet have in your repo, you can run git fetch pb. Okay. Is this an actual repo? Is it going to pull the right information? Okay, okay. Paul's master branch is now accessible locally as pb/master. Oh, we also specify, hold on, because by default it goes for, the main branch or the master branch, but we can also specify like a specific branch to pull to fetch. I think so. I think that is the case. Um, Download objects and refs from another repo. Yeah, yeah. Generally, like, okay, I believe we are supposed to be specifying this information may be used by scripts and other Git commands such as git pull. Okay, I'm not getting too much from that. I guess I'll just I'll ask Gemini later. Um, okay, you can merge it into one of your own branches, or you can check out a local branch at that point if you want to inspect it. We'll go over what branches are and how to use them in much more detail in Git branching. Fetching and pulling from your remotes. As you just saw, to get data from your remote projects, you can run so and so. The command goes out to that remote project and pulls down all the data from that remote project that you don't have yet. After you do this, you should have references to all the branches from that. Oh, it's not pulling a specific branch. Okay, all right. Now, okay, if I open up Git UI and go into branches, remote, okay, it pulled something from PB. Oh, wait, it does actually have two things. It has master and ticket. Okay. All right. By the way, off stream, I have been playing around with the revert and reset commands. And that's why I was able to move on from it because I felt like I understood it. The idea behind revert is I can do it right now. Reverting applies the change. Sorry, reverting, well, it applies the reverting as a change and then records that change, the fact that it actually, reverted. So if I commit this, I should have shown you the text that would be gone. This is the text. So the text is now gone. Um, I can show it from here. Yeah, this was the text that was added in fifth commit, and then I reverted that. So now that text is gone, right? The reverting or reversion, revertment, reverting, the revert action that gets recorded here. And further from this point, now the file doesn't have that text that it had before. Hold on. Yeah. So that line was erased, and like two or three empty lines above that were also erased. Now, this is reverting. This actually gets recorded. Then you have resetting. Resetting allows you to kind of get rid of these commits and reset back to a certain point. So in this case, I don't want to be resetting to this. I want to be resetting to this commit. So I'm going to go to this commit and hit Shift R, and now you can see I have options for, whether I want a soft reset, which is where it'll keep the changes, but stage them. If I want a mixed one where it'll keep the changes but not stage them or unstage them. Um, and we have a hard reset, which just discards all the changes, and it'll bring back the it'll restore the directory back to whatever state it was in fifth commit. So if I accept this, give it a second, there. Now you can see it's back here, and we don't we don't see any changes to stage or commit, and we also don't see the revert commit as well. So that's the difference between revert and reset. And honestly, this can be useful at some point in the future. I doubt I'm going to be like reversing things a whole lot. I mean, I could maybe at some point, but rather than erasing things, which, like with reset, I would prefer to I would prefer to log the changes that I've made. Granted, there would definitely be situations where I might want to, just get rid of all the changes, and also not have any trail of those changes that were being committed. But yeah, yeah. Anyways, it's good to know the command. Now, that being said, give me a second. Okay. Um, hold on just a second. I'm just looking for You know what? We can go to this person. No, we cannot. Okay, never mind. Um, Hold on, I'm still looking. Okay, I think there's someone studying something pharmacy related. Um, okay, okay. Okay, I think let me see if I'm able to go into this person's. Yeah. Okay, cool. Right. So I'm gonna set up the raid. Okay, cool. Yeah, the raid is going through. So we are gonna be raiding into someone named Beth and Barry, I think. Yeah. They are doing. I don't know what they're doing. They're chatting about something. So we're gonna go hang out there. But yeah, yeah, we made some progress today, and that's great. We're gonna continue this tomorrow. Holy shit, the Git stuff is taking longer than I thought it would. I'm wondering if I should just continue with the Git stuff even now off stream, so I can hopefully finish this, and then we can get back to, you know, doing the other stuff that we were doing. Because I definitely have a lot of stuff to be getting done. Hold on. Oh shit, I forgot there's a timer going. This is the stuff that we have to get done. Um, and I'm currently at the top here. But yeah, yeah, okay. That's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.